A regular computer chip can only be in one state at a time, on or off, 0 or 1, no exceptions, ever. But somewhere in a lab in Santa Barbara, there's a chip that breaks that rule completely. It can be on and off at the exact same moment, for millions of instances at once. And when scientists pointed it at a problem in 2024, it solved something in under 5 minutes that the fastest supercomputer on Earth would need longer than the age of the universe to finish. That's not a typo. That's a real machine. And today, we're going inside it. By the end of this video, you're going to understand exactly how a quantum chip works. Not in the hand-wavy, it's just magic, trust me, way most explainers do it, but the actual mechanics. What a qubit really is, how a chip stays quantum without collapsing into useless noise, and the one engineering trick that scientists chased for almost 30 years before finally cracking it. We're also going to get into the strangest implication of all of this, a claim so wild that one of the lead scientists on this project said it might be evidence for parallel universes. This isn't speculation. In December 2024, Google unveiled its 105-qubit Willow chip, demonstrating 2 breakthroughs that had eluded researchers for decades. The results were published in Nature. Let's break down exactly what that means. Here's a question that sounds simple, but isn't. What is a normal computer actually made of at its core? Picture a light switch. It's either up or down, on or off. Every photo, video, and word you've ever typed is just billions of these switches flipping in patterns, what we call bits, a 1 or a 0. That's it. That's the entire foundation of every computer ever built, from the first calculator to the supercomputer that runs your bank. Now imagine a coin spinning in the air. While it's spinning, it isn't heads, it isn't tails, it's both at once. A blur of probability that only becomes real the instant it lands and you look at it. That spinning coin is basically a qubit. A qubit, quantum bit, doesn't just sit at 0 or 1. Qubits can exist in multiple states at once, a property known as superposition. While it's spinning, a single qubit is quietly exploring both possibilities simultaneously. Chain a bunch of these spinning coins together, and you're not just doubling your computing power, you're multiplying it exponentially. 2 qubits can represent 4 states at once. 3 qubits, 8. 100 qubits, more states than there are atoms in your body. But here's the catch nobody tells you. That spinning coin is incredibly fragile. The moment anything touches it, heat, vibration, even a stray bit of light, it stops spinning and collapses. So how do you build a chip out of something this delicate? That's where it gets genuinely strange. If qubits are this fragile, how do you stop the entire universe from interfering with them? Willow is built on superconducting transmon qubits, a type of qubit that stores quantum information in the oscillations of electric charge within a tiny superconducting circuit. This entire field traces back to a 1985 discovery so significant, it won its researchers the 2025 Nobel Prize in Physics. But these artificial atoms are so sensitive that even ordinary room temperature heat, the kind radiating off your body right now, is enough to scramble them into static. So engineers do something almost absurd. They cool the entire chip down to millikelvin temperatures inside a dilution refrigerator, a device that gets the chip colder than outer space itself, colder than Pluto, colder than anywhere else in the known universe. This is the part most people miss about quantum computers. It's not just clever code, it's brutal, physics-defying engineering. just to keep the spinning coins spinning long enough to do anything useful. And even then, even at near absolute zero, the qubits still only hold their state for a flicker of time. On Willow, engineers managed to stretch that coherence window to roughly 100 microseconds, about 5 times longer than its 2019 predecessor.
100 microseconds doesn't sound like much, but it was enough to solve a 30-year-old problem that almost killed the entire field of quantum computing. Here's the dirty secret of quantum computers nobody puts in the headlines. The more qubits you add, the worse they get. Normally in engineering, scaling up makes things more reliable. Not here. Typically, the more qubits you use, the more errors occur. And the system stops behaving quantum and starts behaving classical again. Useless for the very thing you built it for. For nearly 30 years, this was considered close to a dead end.
Add more qubits to get more power, but adding more qubits adds more noise, which destroys the power you were trying to get. A trap. In December 2024, Google published results in Nature showing the opposite was finally possible. The more qubits used in Willow, the more errors were reduced. The more quantum the system actually became. Scientists call this going below threshold. In plain English, for the first time, scaling up a quantum chip made it more stable, not less. Across its full 105-qubit array, Willow now hits gate accuracy above 99.9%, operating at speeds of tens to hundreds of nanoseconds. That's the unlock. And once that door opened, Google didn't just run a party trick. They built something that could be checked, verified, and proven faster than the best classical supercomputer on Earth.
Here's where it gets uncomfortable. Using a technique called the quantum echoes algorithm, Google sent a signal into the chip, deliberately disturbed a single qubit, then reversed the entire process to detect an echo of how that disturbance rippled through the system. The result? A simulation completed 13,000 times faster than the world's most powerful classical supercomputer. And unlike previous quantum demonstrations, this one could actually be verified, meaning scientists could check the answer was real, not a fluke. But here's the twist that should genuinely unsettle you. The head of Google Quantum AI didn't just call this a speed milestone. He suggested the result lends support to the idea that this computation might be happening across multiple parallel universes simultaneously. Invoking the many worlds interpretation of quantum mechanics, first proposed by physicist Hugh Everett in the 1950s. Sit with that for a second. One of the people who built the machine is suggesting it might be borrowing computing power from realities that aren't ours. That's not confirmed science, it's an interpretation, and plenty of physicists push back on it. But it tells you something important. We are now building machines so strange that even the people running them aren't sure what reality they're tapping into. That's the dark, dizzying edge of this technology. Not killer robots, but a quiet, growing uncertainty about what computing even means anymore. So strip away the jargon, and here's the one thing to actually remember. A quantum chip isn't a faster version of your laptop. It's a fundamentally different kind of machine, one that uses the weirdness of physics itself, superposition, near impossible cold, and a 30-year error correction breakthrough, just to ask reality a question and listen for the echo. This isn't science fiction anymore. Google is already treating this as a stepping stone toward a 1 million qubit fault-tolerant system built for real-world problems in medicine, chemistry, and materials science. But a machine this powerful raises an obvious next question. If quantum computers can break problems classical encryption was built on, what happens to your passwords, your bank,
your private messages.
That's not a future problem. Some experts say it's closer than you think. Click the video right here, where we break down the quantum threat to encryption and whether anything you do online today is actually safe tomorrow.